Hello everybody, and welcome to the beginning of section 2.3. We are looking at page 44 in the workbook. And just to remind you of kind of the general path that we're on here, chapter 2 is about learning shortcut formulas for taking derivatives of functions. As we continue through this chapter, we're going to build our toolbox bigger and bigger with tools that we can use to take derivatives of functions. Okay, and our next step along the way is to talk about something called the product and the quotient rule. Okay, so let's start with the product rule, which is the first of these two formulas, and it asks the question, how would we take the derivative of the product of f of x times g of x? Okay, now you might look at this and say, well, it seems like if we take that derivative, we should just get f prime of x times g prime of x, the product of the derivatives. Unfortunately, it's not quite that simple. Products are kind of tricky things, and so let me show you how it actually does work when you take the derivative of a product of two functions. Okay, what you actually get is f of x times g prime of x plus g of x times f prime of x. Okay, in other words, you get the first function times the derivative of the second function plus the second function times the derivative of the first function. This is what's known as the product rule. Okay, and if you're wondering where that comes from, basically, to prove this, you would go back to the limit definition of the derivative, and if you do that and do a bunch of algebra, you can arrive at the formula that we just wrote down. Okay, if you're curious, you could either look in our textbook or maybe Google product rule proof. I'm sure you can find a demonstration of where this formula comes from if you're interested. Okay, and then the second formula gets even more interesting. What if we want to take the derivative of the quotient of two functions, f of x over g of x? Okay, well, let me write this formula down. This is going to look pretty wild the first time you see it. Okay, that's a lot of stuff. This is what's known as the quotient rule. Okay, and I'm going to share with you just a little jingle that my high school calculus teacher taught me way back when. This has stuck with me for 32 years, so you might try it out. So I'm going to give the top and the bottom functions names. Let's call f of x the high function because it's in the top, and g of x the low function because it's in the bottom. Okay, if you think of those two functions as being high and low, and look at what this formula is saying, we start with g of x, which is the low function. We take the derivative of the high, so I'll call that d high. Then we go minus high d low. And then on the bottom, low squared. So if you put it all together, low d high minus high d low over low squared. Okay, it sounds kind of silly, but you'd be amazed how that sticks with you if you say that a few times. So try that out. It might help you to remember this formula. Okay, well, let's see if we can do an example. Just put these formulas to work for us. Let's say that we want to take the derivative of x squared times x cubed. Now, which of these two formulas do you think would apply to this situation, first of all, product rule or quotient rule? I'd probably choose the product rule because we're looking at two functions multiplied by each other. Okay, so let's try it out. Just see what it tells us. Okay, so if we go back and just kind of look at what the product rule is telling us, it starts out with these two terms. So the first function times the derivative of the second. So the first function in our case is x squared times the derivative of the second one. Okay, there's the first part of it. And then we come to g of x f prime of x. That's the second function times the derivative of the first. So x squared times the derivative, x cubed is the second function, times the derivative of the first, which is x squared. So we've just written out the product rule. And if we actually do the calculations here, notice that there are two derivatives that we still have to take to finish, the two pieces that have d dx's in front of them. So we'll start with d dx of x cubed. How do you take the derivative of x cubed? Well, that's the power rule. And we saw that a lot in the last section. Derivative of x cubed is just 3x squared. Okay, and then moving on to the second piece, we need to take the derivative of x squared. So we've got an x cubed, and then the derivative of x squared would just be 2x. Okay, let's simplify this a little bit. So x squared times 3x squared is 3x to the fourth plus 2x to the fourth. And we could even go one step farther and add those together because they're like terms and get 5x to the fourth. There's our answer. Okay, now question for you. Do you see a different way that we could have done this problem? Maybe an easier way? Okay, well, if you go back to where we started, the derivative of x squared times x cubed, a second alternative here would have been to simplify before we even take the derivative. What do you get if you take x squared and multiply it by x cubed? If you add those exponents, you get x to the fifth. And what's the derivative of x to the fifth? By the power rule, that's just 5x to the fourth. And notice, same answer as what we got up here. Okay, so now you might be asking, why in the world would we torture ourselves by doing it the long way that we did up here? That was a lot more work than just doing it this way down here. Well, the point of this first example is just to kind of convince you that the product rule works at least for one example. Okay, so in the future examples we will see examples of functions where it's to our benefit to use the product rule, where that's the good way to do it. Okay, so hold that thought. We will continue with that in the next video.